kinds of things. Welcome to another ATAR Notes lecture. If you haven't already, I recommend looking at the ATAR Notes website to see the different resources there. We've been providing resources for over a decade now, so there's definitely been a fair bit built up, and I would recommend you look there. So this includes a range of free resources, obviously the lectures. For me personally, one of the things I found most valuable was actually the discussions that I had with other students, but there are also other things like free study notes, videos, those kinds of things. There are also paid resources where you can get a bit of that extra support, extra help. For example, I run the psych class on Tuesdays at 6 p.m. So we've recently gone over our second research methods focused lesson of the year, and if you're interested in that, look on the website. Other resources such as study guides or Ed Unlimited, which gives you access to all of the study guides and to practice exams and things like that as well. Again, if you're interested, check out the link. I want to give a big thank you to our university sponsors. So special thanks, in particular looking at La Trobe and all of the other universities who have helped out, such as RMIT and Deakin, so that you can have these free lectures. Speaking of La Trobe, they are also running the Aspire Early Entry program. This allows you to get an early conditional offer to La Trobe University. So if you're someone who is involved in your community, I would recommend that you look into this, see if you meet the criteria and make an application, so that you can potentially get an early offer from La Trobe. In terms of this lecture, as I've said, we're focusing on Unit 3. So we've got a bit of scientific skills at the end there, but really we're focusing on trying to get that Unit 3 content down. In some places, I'm going to be going through pretty quickly. Please feel free to ask questions, even if it's not something I've explicitly covered in the lecture. Feel free to ask about that and to respond in terms of any of the practice questions as well, or asking further feedback if you're watching the live stream. There are some places we're going to be skipping through the slides pretty quickly. It's more there so that you've got that slide as a reference in your notes. So just be aware of that as it happens. And if you have any issues accessing things like the slides, again, please let me know so I can try to help you out. All right, first of all, we've got the divisions of the nervous system. This is a classic, so this isn't new to this study design. It's something we've had in previous study designs for ages and ages, heaps of practice questions on it. So we know we've got the nervous system divided into the central and peripheral nervous systems, and then our peripheral nervous system, we've got the somatic nervous system and autonomic nervous system. I find that often students will make mistakes they'll remember that the somatic nervous system is responsible in terms of controlling our skeletal muscle movements, like moving our limbs, things like that, those voluntary motions, but they'll forget about its important role in terms of gathering sensory information. So make sure you remember that one. And then we've got the autonomic nervous system, which is split into the sympathetic and the parasympathetic nervous systems. You can think sympathetic for stress, parasympathetic for peace or parachute slowing things down. We know that the sympathetic nervous system, we're going to deprioritize things like digestion that can maybe wait a little bit, and we're going to focus really on our short-term survival. Whereas parasympathetic nervous system, we're going to recuperate our resources a bit more. So we've got our central nervous system, which consists of the brain and spinal cord, and everything else is peripheral. And then when we look at our different divisions, we can see that they have these different roles. So you can see, it's all in here, again remembering sensory information for the somatic nervous system as well, and the role of our autonomic nervous system. When we're looking at sympathetic and parasympathetic, make sure you have a few different examples and you could pick it out in multi-choice in terms of what's going to be prioritized when the sympathetic nervous system is dominant versus when parasympathetic is. The spinal reflex is something that often people can make mistakes on in terms of where it falls in those divisions. So the spinal reflex, because you're using for example, moving your arm away, that's using your skeletal muscle. So your somatic nervous system is involved there. Your autonomic nervous system is not. So when information about a potentially harmful sensory stimulus, e.g. heat from a hot stove, reaches the spinal cord via the sensory neurons, so those sensory neurons, we're thinking somatic nervous system, and then the spinal cord, is central nervous system. Interneurons in the spinal cord, because all of our neurons in the central nervous system are interneurons, relay the message directly to the motor neuron. So what we're having happen is stimulus comes in, reaches spinal cord cord's going to go, okay, I'm going to directly relay this to motor neurons. Got to act fast here, and we'll save time by, directly sending a message rather than waiting for the okay in the brain to decide what to do. So the motor neurons are going to carry the motor message back to the muscles involved, and often this is a withdrawal reflex, get away from the source of the danger, which can happen before any pain is actually felt. While the motor information is being carried to the hands, the sensory information is still being sent to the brain, so along those afferent pathways in the spinal cord where it will be processed. So that's going to include information that causes the pain response, which you can have a bit of that delayed reaction, because remember that the brain is not initiating this movement. So often in the higher mark spinal reflex question, there can be 1 mark for recognizing that although the brain doesn't make the decision here, information is still sent to the brain. In terms of how these neurons are sending messages about, in this study design, we're not seeing a big focus on labeling the different parts of the neuron explicitly in the study design, but you still need to know how neural transmission works. So we've got a synapse in here, and you can see that we've got the axon terminal of our presynaptic neuron, which is coloured in purple, and the dendrites of our postsynaptic neuron, which is coloured in blue. So in the axon terminal, we have these dots, which are representing neurotransmitters being released across the synaptic cleft or gap. So they're going to diffuse, drift across, and then they're able to anneal or attach to those receptors on the dendrite or on the postsynaptic membrane is another way of phrasing it. So it's really important here that the neurotransmitters go to the receptors. They are not going through the channels. After the neurotransmitters attach to the receptors, we then have some signal transduction happening, which you don't need to know any details of. You just know that then this can signal for the ion channels to open, allowing ions to flood into the dendrite. After this is done, you can have enzymes come through and clear away these neurotransmitters, freeing up the space for our next time we want to send that signal across. We can also have reuptake channels on our axon terminal where the neurotransmitters can be taken up so they can be used again in future. In terms of the effect that a neurotransmitter has on the neuron firing, this can be either excitatory or inhibitory. So our excitatory neurotransmitters increase the likelihood of a neuron firing. You need to know glutamate as an example of this. And our inhibitory neurotransmitters decrease the likelihood of a neuron firing. So for example, GABA or gamma-aminobutyric acid. So then we can consider, alright, if it's had a lot of excitatory inputs and not really much inhibitory, we would consider it quite likely that the postsynaptic neuron would fire versus the opposite. Another thing to think about here are that we can have agonists and antagonists. So agonists are something that were mentioned in the previous study design, but at the end of the year. And so we've got antagonists specifically and explicitly in this study design, and you need to know about them for Unit 3. So our agonists are substances that are going to increase the receptiveness of our dendritic receptors to a particular neurotransmitter. And the key example to know here are benzodiazepines. You don't need to know about the mechanisms, but this is just to give you an example of how it can work. Benzodiazepines can bind to the GABA receptors in a different spot than where GABA actually binds. So this is then going to change the receptor shape, which makes it easier for GABA to bind onto the receptor. So they're increasing the effect of GABA in the brain. And we know that GABA being an inhibitory neurotransmitter, It's nice for like slowing things down, and benzodiazepines can be used as an anti-anxiety drug. We also have substances that are going to do the opposite thing. So instead of making our receptors more receptive, they're going to decrease the receptiveness of your dendritic receptors to a particular neurotransmitter. So these are your antagonists. For example, caffeine is going to act as an antagonist for adenosine by blocking the binding site. You don't need to know the specific example. I know some people were a bit freaked out. There's a question in the 2017 exam that talks about caffeine acting as an antagonist. You weren't expected to have specific knowledge of that. It was more about knowing the general role of agonists and antagonists and applying that within the scenario into the question. We've got also neurotransmitters and neurohormones. So our neurotransmitters are chemical messages produced by neurons released into the synaptic gaps. So they're going from neuron to neuron. We also have neurohormones, which are chemical messages produced by neurons, but they're released into the bloodstream where they're carried to other neurons or cells. Our neuromodulators are going to have effects on a group of synapses, so a bit less specifically focused on one. We know that in general neurohormones are going to be slower than neurotransmitter communication. Happens for any sort of neurotransmitter versus hormone communication, where hormones will be slower. We also want to think about how the response that the neuron has can change due to synaptic plasticity. So know that the brain is quite able to adapt, and synaptic plasticity is a specific type of neuroplasticity where we're having synapses change over time. So we have LTP, which is long-term potentiation, and LTD, which is long-term depression. In LTP, it's neurons that fire together, wire together, which is called Hebb's rule. So we have an increase in the strength of our neural pathways due to repeated activation. So LTP increases the likelihood that if a presynaptic neuron fires, the postsynaptic neuron will fire too. Then we have LTD, which is like use it or lose it. Long-term depression is where we have a decrease in the strength of our neural pathways because it's not being activated very frequently. So if we have our presynaptic neuron firing, the postsynaptic neuron isn't quite as receptive to that. It's less likely to fire. When we combine these together, what it means is that the strength of our neural pathways are modified based on frequency of use. So the things that get used more than neural pathways you're used to using become easier and easier to trigger again and again. The things that you're using less, then that's going to be weakened, and so it's not going to be as sensitive to firing. So to have this actually happen and get this stronger synaptic connection between neurons in long-term potentiation, we can have things like an increased number of synapses, increased number of receptors, releasing more neurotransmitters. For long-term depression, where we have a weaker synaptic connection, this can be through things like a decreased number of synapses, a decreased number of receptors, decreased amount of neurotransmitters. So sometimes people will talk about things like dendrite bushiness here. This has been in the study design before, so you do have resources on this. We have some specific terminology that's been introduced into this study design as being that you need to know it. Talking about how we change our neural pathways. So you have sprouting, where additional synapses are created. This allows you to create new pathways or strengthen ones that already exist. Pruning, where we're going to get rid of stuff, so we're having loss of existing synapses. This is helpful because it can allow you to lose maladaptive pathways that actually aren't that helpful to you. You don't want them. And it also increases efficiency. We also have rerouting, where alternative neural pathways are created using active neurons, enabling the loss of existing pathways. So instead of going from like A to C using B, you can now go there using D instead. I wanted to talk a bit more about neuromodulators because these are new to the study design. So we have neurotransmitters released at the synapse affect the flow of ions into the postsynaptic membrane. Neuromodulators are released near a group of synapses and are going to affect pre- and or postsynaptic activity. Neurotransmitters will act a very short time frame, whereas neuromodulators can act over seconds and minutes, so longer than our neurotransmitters. If you look this up online, there are some sources that will tell you that neuromodulators are a type of neurotransmitter, but the study design asks us to compare them, so I wouldn't treat them that way in the context of the study design. Just a fair warning there. For our neuromodulators, we specifically focus on serotonin and dopamine. And if you go back through the exams from the previous study design, you'll notice that there are questions on dopamine in the context of Parkinson's disease. So although Parkinson's disease isn't something we really specifically look at in this study design, I would learn it anyway because it's going to really tie into the stuff that you need to know about dopamine. So our key information, serotonin and dopamine are both neuromodulators. Most of serotonin is not in the central nervous system. Most of it's not in the brain. A very high amount is in the intestines. So when we look at things like the gut-brain axis, we can link that in as well. Both can have various different effects, depending on where they're released from, where they're acting. So effects on long-term potentiation is just one example. And abnormally high or low levels of either are associated with illness. So for example, with serotonin, we can look at digestive issues. Dopamine, we can look at Parkinson's disease in terms of these more directly physical and physiological changes. Both are also implicated in a range of mental illnesses and being able to have an impact there. So if we think about Parkinson's disease, because dopamine is an important with an excitatory role and like initiating motor movements, when you have death of neurons responsible for producing dopamine, this then results in the symptoms of Parkinson's disease, such as impaired control of voluntary movements. I'm not going to spend too much time on this because it's not explicitly in anymore. We can see another case where we have a change in neurotransmitter functioning then having various different impacts in Alzheimer's disease. So Alzheimer's disease is something that was in the previous study design, and often look at it through this lens where we have our beta amyloid plaques, neurofibrillary tangles, and we have medial temporal lobe shrinking, especially affecting the hippocampus where we have death of neurons, to issues forming memories. For this study design, I would make sure that you look up like brain imaging scans in case you get questions on those in relation to Alzheimer's disease. We know that post-mortem studies are quite important because you can't really cut open someone's brain and examine it while they're alive and expect that to continue to be the case. So I would look at it more in that context. This is something that in this new study design is actually situated a bit later when we're looking at the memory side of things. Now let's start to go across into stress. I'm not going to spend a huge wealth of time here because this is often content that people might find a bit easy. It's probably a bit more recent for you in terms of your studies as well. Just going to quickly go through eustress, more like euphoria, your positive response, like enthusiastic, excited. Distress, negative. This is more commonly what we think of when we think about stress. And we have various different sources of stress that can contribute to this. In this new study design, instead of calling it fight, flight, freeze, it's being called fight or flight or freeze response. So we'll try to get used to that phrasing, where we're thinking about an immediate threat, activating this response without our conscious control, so it's involuntary, to fight, flight, or freeze. We have accompanying physiological changes. Make sure that you know a few examples of these. And all of these can be adaptive in the right situation. For example, freezing can help you be still and avoid detection. I want to make sure, however, that I spend a bit more time when we talk about the HPA axis because this links in to the gut-brain axis. So HPA axis is where we have the hypothalamus, pituitary and adrenal gland work together in this kind of response to stress. So the hypothalamus is going to be alerted to the presence of threat by the amygdala, which is really great at responding to fearful things. And the hypothalamus is going to coordinate hormone release here. The pituitary gland is going to release adenocorticotropic hormone, or ACTH, which is then going to signal to the adrenal glands to produce more cortisol, which we know is a stress hormone, and particularly implicated in longer-term stress than our just immediate snap response. So cortisol can be quite beneficial for us in terms of increasing our blood sugar, so we've got more energy to deal with this in the short term. But the level of cortisol is a strong predictor of stress levels. High levels of cortisol over a prolonged period of time can reduce how effective our immune system is through doing things like making our white blood cells, which fight disease, less effective and can therefore contribute to illness. Our HPA axis is going to take longer than the fight, flight, freeze response, or fight or flight or freeze response to activate and take effect, and its effects will last for longer as well. So adrenaline, we think more about acute stress, and cortisol, more chronic stress, longer term. Make sure that you know your general adaptation syndrome by Hans Selye, where we have our baseline level of resistance, which drops down immediately in shock. Then counter shock, we're starting to see that go up. We're releasing our stress hormones to help us cope with this stressor. Resistance is high, and then partway through exhaustion, it crashes down and goes below normal. So you want to make sure that you can recreate this graph, list the different stages, know key things associated with each stage. So towards the end of resistance is where you see your more like minor illnesses, and then exhaustion is where you see more of the serious stuff like, heart disease problems, for example. And try and, if you get a question on this, back it up with a plausible explanation for why you can get that effect in there too. This is something that was in the previous study design, so there's a whole bunch of questions on it, and will likely be a bit easier to learn. The gut-brain axis, however, is newer. So I've created this flowchart based off the studies that VCE has put in their resources lists, where we have a change in microbe composition in the gut, which is then going to go, okay, we've got different microbes, so like different bacteria and things like that. This is then going to mean we have different bacterial molecules present, so things like components of bacterial cell walls that are going to change due to what bacteria we have. These bacterial molecules can be directly detected by neurons in the hypothalamus, thus affecting the brain. What we can also have happen is our cytokines, which are these proteins used by the immune system to send signals, can then have alteration due to these bacterial molecules being present. And then those cytokines have an influence on brain activity. This cytokine response can then lead to easier HPA axis activation. And we know with our HPA axis, we can get more cortisol, which is going to impact the gut and the immune system. We can also have that this cytokine response makes our intestines more permeable. So it's going to be easier for our bacterial products, our bacterial molecules, to reach the brain and have an effect that way. So what you can have here is that you might have a more like stable, healthy state and a kind of stable, unhealthy state, where it can switch between them if you have some different change come in. And we also know that not only does the gut impact on our stress and on our brain, but we also have the inverse relationship as well, where people can, for example, consume their diet differently in response to stress they're experiencing. So one of these studies that was recommended also looked at the benefits of having a prebiotic. So this was based on studies using mice. So like when we talk about the limitations of the general adaptation syndrome, because it was based on these studies in mice where we can't necessarily generalize it to humans, we have the same caution applying here. But our prebiotics, then where we're having beneficial bacteria, commensal bacteria taking up more of our gut, we're then going to have changes to our cytokines, which could result in less inflammation, reduce intestine permeability, so it's harder for our bacterial proteins to reach neurons. We could have improved HPA functioning and less stress hormones as a result. Now I'm going to go on to Lazarus and Folkman transactional model of stress and coping. So we have some sort of stressor, our primary appraisal being like, do I even need to worry about this? Am I in trouble? And then we're going to appraise it. Okay, is it irrelevant, benign, positive, or stressful? If it's stressful, we'll then go, is it harm, loss, threat, or challenge? Sometimes students struggle a bit to differentiate between harm, loss, and threat. Threat is more focused on the future consequences. Harm, loss is you're more focused on what's already happened. So say, for example, someone's lost their job. If in this scenario it's telling you about how they're so worried that, like, maybe in the future they're not going to be able to pay their bills, they're really focused on the future threat there. So you want to put it down as threat. If they're focusing on like, oh no, I've lost my job, now I've lost all my prestige that I had from working there, I'm not going to be connecting with my colleagues, what have you, then I'd put it down as more of the harm loss. If on the other hand they're like, oh, you know what, this is great, I can get a new job, I can, spend my time on different things, maybe I can bring something positive out of this, you might put it down more as a challenge. After our primary appraisal, we have secondary appraisal, which is where you think about the coping resources that you have available. So your coping resources include a whole range of things. This could be having a friend to vent to, having some money, having this technique that you know. So we've got coping strategies that come into play with this as well, with emotion-focused coping and problem-focused coping. And what you might do is, after thinking about your resources that you have, reappraise your stress and actually decide, you know what, this isn't that stressful for me anymore. When we're thinking about using our coping strategies effectively, what we really want to think about are context-specific effectiveness, where your coping strategy is going to match the stressor well. For example, if you have a big test coming up, it's probably not going to be the most effective thing to take on an avoidance strategy where you just procrastinate and scroll social media, and it might be a bit more effective to use an approach strategy where you potentially study a bit. But you also want to have coping flexibility, and this is going to allow you to have more context-specific effectiveness because you have a range of different coping methods. So say, for example, this person's really good at their approach strategies and studying all the time, and then they do their exam, and they're stressed about the results that they got on that test. They're like, oh, I don't know what it was, I don't know if it was good, and then they keep studying for that same test they've already done. That might not be so effective anymore. In that case, it might be better for them to try and distract themselves from that, focus on other things. And so someone with high coping flexibility is going to be able to change their coping strategy. And people with high coping flexibility, who can have great context-specific effectiveness, tend to handle stress more effectively. So we can think about our approach and avoidance strategies, where approach ones involve direct efforts to confront a stressor, and avoidance strategies are more about evading it and not kind of dealing with it. Each of these can be useful depending on the situation, but often the approach coping strategy might be a bit more adaptive. That's our nervous system and stress part. So we're going to go on to learning now. With learning, you can see here the type of learning that we're looking at is classical conditioning. And we know that it's classical conditioning when we get it in a scenario because it's involuntary. We have before conditioning, during conditioning, and after, and we have this very specific language. So before conditioning, our unconditioned stimulus elicits the unconditioned response. So remember, the unconditioned stimulus is the one where it gives you a response without conditioning because it's normal for it to have that response already. Your neutral stimulus, we're going to call neutral because I don't really care, it doesn't get any particular response. So our neutral stimulus does not elicit the conditioned response. During conditioning, we have repeated pairing in which the unconditioned response and the neutral stimulus are associated together because of the unconditioned stimulus and neutral stimulus being repeatedly paired and being presented within a short time frame. So sometimes it matters whether you mention the very short time frame that they need to be presented in. Sometimes there's not a mark for that. After conditioning, your neutral stimulus has now become a conditioned stimulus, which we know because it elicits the conditioned response. So I've got more of a breakdown of the terms here. So if you're maybe a bit less familiar with this one, we've got the different ones here in terms of Pavlov's experiment, what each part is. The thing I would say here is the little Albert experiment often is going to be something that you learn as an example. Don't stress about knowing the little Albert example or the Pavlov example with these dogs specifically. You don't specifically need to know about little Albert ethics anymore. It's not explicitly listed in the study design, but you do still need to know about ethics in general. So I would still recommend that when you're doing your past exams, you go through and you answer these questions anyway, because you've probably learned about this scenario when you're being taught classical conditioning, and then you can apply this as a chance to practice your ethics. So make sure you remember things like withdrawal rights if you've got a toddler, crawling away, trying not to participate, the fear response not being extinguished. So we might be thinking about lasting psychological harm here. And of course, informed consent being quite important in terms of knowing the purpose of the experiment, what the risks are, and what is happening there. When we're looking at conditioning, we also have a stimulus generalization, where a stimulus similar to our conditioned stimulus produces a response similar to the conditioned response. This happens when we have our objects being quite similar to each other. For example, Pavlov's dog salivating at the sound of a doorbell instead of a normal bell. Or we have stimulus discrimination, where you only get the response for the conditioned stimulus and not to some other stimulus. For example, Pavlov's dog salivating to the handheld bell, but not to the sound of other bells or other bell-like sounds. We can also look at extinction, where we see a decrease in the strength of the response. We're no longer having that association, it's becoming weaker and weaker, and so eventually we can have extinction occur when a conditioned response doesn't occur at all in response to the conditioned stimulus. We can also have spontaneous recovery. So this is after extinction is thought to have occurred. Then you have a rest period, and then you present your conditioned stimulus again, and the conditioned response reappears. So this tends to last a bit less. It's faster to have it go away again, be a bit weaker than what it originally was. And eventually you tend not to get any spontaneous recovery anymore. So we have classical conditioning. We also have operant conditioning. So together these are our behaviorist approaches. With operant conditioning, we can still have things like extinction and spontaneous recovery occur. So all of those terms are important to keep in mind. Operant conditioning, like classical conditioning, is a three-phase model. With operant conditioning, it's ABC, so we have antecedent, behavior, and consequence. The antecedent is the stimulus that prompts the response, our behavior is the voluntary response, and the consequence is the outcome. Sometimes you'll get scenarios where you have, multiple people being conditioned at once. So, for example, let's think about a child at the shops from the child point of view. The child enters the shop and sees lollies. The child yells at the parent for lollies, and then the parent's like, you know what, here you go, here you can have some lollies. We know that that's going to be a positive reinforcement, and the child will be more likely to yell at the parent for lollies in the future. From the parent perspective, the antecedent is the child yelling for the lollies. The parent reaction is their voluntary behavior, and then we've got the child response. So let's say the parent goes, yeah, okay, you can have your lollies. And so the child's being positively reinforced. But then what the child does is it goes, and it keeps yelling anyway. Then the parent's less likely to do that again in future because they didn't get any reinforcement. And so, we might not expect this cycle to continue. But if the child, on the other hand, was quiet, we know that the parent would have been positively reinforced because the unwanted stimulus of the child yelling has been removed. So it's really important that we can categorize our consequences and think about what they're called. Remember that positive is we're adding something, we're presenting something, it's in the environment. It doesn't mean that it's good or wanted. Reinforcement means we're reinforcing it, we're encouraging it, we want to make that behavior stronger, more likely to occur in the future. and punishment, we're trying to discourage the behavior. So positive reinforcement is where we're going to add something in order to encourage the behavior. So this will be something like giving the child lollies. Negative reinforcement is where we're going to remove something, and then that's going to encourage the behavior. So for example, removing the child's like yelling or complaining is going to encourage the parent to give the child lollies. But we can also have positive punishment. So say, for example, the parent response was to like tell off the kid or be like, no, you can't like have your iPad anymore, whatever it might be. Then this is going to decrease the likelihood of that behavior occurring in future. And we could also have negative punishment. So for example, kids can be pretty receptive to whether their parents are paying attention to them, and the parent might, withdraw that attention that they'd normally get, or take something out of the trolley that the child wanted. And then this is going to be a different means of discouraging the behavior. So our previous ones that we looked at, classical and operant conditioning, there are behaviorist approaches. The term behaviorist approach is new to this study design, but operant and classical conditioning have been in many successive previous study designs. There are heaps of questions on them. I really encourage you to do them. There's some, easy multi-choice ones, but then also you'll learn that with the short answers, there can be a nice kind of formulaic word answer you can learn where you slot in the scenario. So I would recommend you get used to that phrasing so you're able to get full marks. From learning, we can also look at a socio-cognitive approach. So we've got an example of this where we have Bandura's experiment where the children are split into groups, and then they see the behavior of an adult, which we'll call the model, and how that model is treated. So they watched a man hitting a Bobo doll, and then either was rewarded or he was punished, or they didn't see any of that. And then that went on to influence the children's behavior. When we're looking at social learning theory or observational learning, we have these different stages, and sometimes it has been very particular with the phrasing that you have to use. So you need to remember these different stages and be really clear. I often don't advocate for memorizing definitions, but here I would learn the word for word. This is what you're expected to say. Attention. The learner pays active attention to that model. That active is important. They're not just kind of sitting there and they're in their field of vision. They're paying attention to what's going on. They're choosing to do that. It's active. So this might be something like, the child pays active attention to the man hitting the Bobo doll. Then we have retention. The learner forms a mental representation of the model's behavior. It's not good enough here to say the learner remembers it. Usually, you're not going to get any marks for that. You need to say that they form a mental representation of the model's behavior. So the child forms a mental representation of the man hitting the Bobo doll. Then reproduction. The learner converts the mental representation into action. So this might be something like the child converts the mental representation into their action of hitting the Bobo doll themselves. You can also then have reinforcement. With observational learning, we can have vicarious reinforcement where, okay, I saw that the man got lollies for doing that. I'm going to be more likely to do it now because he was rewarded, or I'm going to be less likely to do it now because I saw him be punished. But you can also have direct reinforcement where the child hits the Bobo doll and then, for example, gets praise or criticism, which can then tie in to motivation, how motivated they are to do the activity. So this is a very active form of learning, more active than operant conditioning, which in turn is more active than classical conditioning. And at any stage, we could have values here. For example, you could pay attention to the model. The model might be someone you like or someone who's similar to you or you hold in high esteem. So you're really likely to pay more attention to them. And then you form your mental representation of it. But you are watching an Olympian do a sports feat and actually, you lack the fitness to do that particular thing. You're not going to be able to reproduce that behavior, even if you're highly motivated to do so and reinforced vicariously by them getting medals and that kind of thing. In terms of learning, we also look at ways of knowing by Aboriginal and Torres Strait Islander peoples. For this, I don't really have a huge amount of time. I honestly don't feel like I can do this topic justice in the limited time that we have in this lecture. If you look at the VCAR website, they have like lists of suggested resource activities and that kind of thing. And when you look at it for this topic, you will see different things like, if available, going on a guided tour with an elder, or having an elder come in and give a presentation. In terms of ways of knowing, some of the key advice I would look at, try to find things local to your area. For example, I grew up on and I live on and I'm presenting from land where the Wurundjeri people of the Kulin Nations are the traditional custodians of that land. And so I'm more likely to look at resources that are connected, to that country, and things for that. If you're unsure where to go looking, there are different lists you can look at. There's also, VCAR's released specific guidance in relation to the memory topic, and I found for me that, as a non-Indigenous person, that my understanding of this topic was also helped when I learned more about the connections that we see in memory. In there, they've got, in that guidance, resources that can indicate more, for example, if you don't know who the traditional custodians are in the land that you're on, where you can see maps and look information in relation to that. I have put in some information here about linking to The Guardian, which produces different news articles, because it's often written by academics, written for a general audience so that you can understand it. The conversation is a suitable resource for VCE Psychology. VCAR have used excerpts from the conversation before in exam materials, and you can look here as one of your sources for gaining more reputable knowledge when it comes to this, because I know sometimes on the internet it can be confusing to know where to look. Pay very particular attention when you're looking at the study design. The phrasing of that is very particular. So when you see as a system of knowledge patterned on country, that is very intentional. So you can see things like a story might be told about a young woman who goes into an area who she's not supposed to, and then she gets turned into a lizard that makes this kind of go back motion. So that teaches not just about the behavior in ecology or animals that you see in the area, but also teaching you about what's allowed, what's permissible, what's not. And that's something that you often see in this context where you have a lot of integration, and it's not considered always really separate, siloed knowledge. So that's another thing I would consider when it comes to this dot point. But again, I really recommend that you do a lot of this reading for yourself, because for me, I found that something that I wasn't very used to or familiar with. And so it took a bit of repeated exposure for me to go, okay, these are the key themes that are really emerging, and to gain more confidence in terms of being able to teach that. So for learning within a system, one of the examples that we really look at, and particularly with memory, are about songlines. And I would encourage you to forward links here with other areas of the study design as well. So a lot of this we're looking at, the idea of patterned on country. We know country is not just about their physical geography, but considering the more holistic and interconnected elements as well. With the hippocampus, which is responsible for consolidating your declarative memory, that also has a spatial map in it. So it makes sense that if you're looking at knowledge that's really tied in to where you are, that this could help with integrating that knowledge and strengthening it in. Another thing when we're considering memory is that we have this process called elaborative rehearsal, where as we tie more connection onto knowledge, that can strengthen the encoding of memory. So more meaning and more connection is going to increase your success. And as I've kind of briefly mentioned, when we are looking at this topic, we see a lot of interconnections being forged, a lot of meaning being integrated together. And so it makes sense that you can see some really strong outcomes from that sort of approach. One of the specific examples that we consider sung narrative. Sometimes when you're looking at, I know in an Aboriginal context, this can be not with like, a huge range of like instruments, for example, and sometimes it can be described as a form more of like poetry, as opposed to what you might think of as singing. Again, I'm trying to be careful here not to generalize because there's so much diversity that you have, and also because my knowledge is fairly limited when it comes to this. But you have frequently multiple different areas being taught about at the same time. And when we're thinking about a songline that connects like across various different locations and is really tied into the landscape, in addition to having this more like spoken information, which can have like instrumental or beat accompaniment, you can have other actions in there as well, which are going to add to that. For example, dance, e.g. showing how like kangaroos move, they add more information to tie in and strengthen that knowledge. So as a basic example of where we're thinking about, it's easier to remember frog, water, swim, because those words have meaning to us. Whereas if we look at like cheer, it's going to be a lot harder to understand that. So where we've got more meaning, it's easier to have those memories come in. As mentioned, the hippocampus has a spatial map composed of place cells, except when someone is repeatedly using and accessing this, we can strengthen that layout as well. We know that, for example, taxi drivers who have learned this real large network of streets, then to have an enlarged area for it. So it makes sense that if people really dedicate themselves to, practicing techniques that rely a lot on location, that they're going to develop a spatial map, which is going to be stronger and more integrated. So this could be one reason for the success that we see in terms of being able to transmit generation over, thousands and thousands of years without needing to rely on techniques like writing that information down. All right, I have an example question here for identifying a similarity and a difference between operant conditioning and social learning theory. So if you want to answer this, I would recommend that you pause because I will go across to the answer. Okay, so similarity and a difference between operant conditioning and social learning theory. You'll notice that a lot of students made a mistake on this VCAR question, and only a relatively small amount were able to achieve full marks. So the high scoring responses noted that both forms of learning rely on consequences, i.e. reinforcement, punishment, of voluntary behaviour. Remember that classical conditioning is the one that deals with involuntary behaviour. But that with social learning theory, we can have this occur indirectly via observation, which we can also call vicarious conditioning. However, in operant conditioning, the consequences of behaviour are directly experienced. Other similarities you could talk about included that the learner is active in both forms of learning, the learner is motivated in both forms of learning, and that both rely on voluntary motor responses. Again, these are things that would not be true if we're talking about classical conditioning. They also accepted that operant conditioning has 3 phases, whereas social learning involves 5 stages. And because this was a similarity and a difference, you needed to make sure you were explicit about, you're saying that, in both of these or in this, whereas in that. So being really explicit with your contrasting. Okay, now we're going to head across into memory. Here we have our sensory memory, which is divided into iconic memory and echoic memory. We also have other forms like haptic memory, but we don't really worry about those in the study design. Then we've got our short-term memory and our long-term memory. And you also need to know about various different types of long-term memory as well. So let's first look at the Atkinson, Schifrin multi-store model of memory. This is something that again has been in for quite a while. We have our iconic memory, which has a very short duration, unlimited capacity, echoic, a bit of a larger duration, a few seconds, but still an unlimited capacity. So our sensory memory have our sensory information coming in, and so we can take a huge amount of information for a very short time, and then we select what we're going to pay attention to, and that's what goes into our short-term memory. Our short-term memory has a duration of up to about 30 seconds and a capacity of 7 plus or minus 2 items, which you could also write as 5 to 9. Then we can consolidate memories from our short-term memory into our long-term memory. So this has a virtually unlimited duration and capacity. Of course, we can forget things, we can have various types of interference going on, but theoretically, unlimited duration and capacity. We also have our different types of rehearsal. So maintenance rehearsal, we're going to repeat the information in order to sustain it in short-term memory. In elaborative rehearsal, we're going to link our new information in a meaningful way with other information that we have, which is going to help with storage and future retrieval from long-term memory. In the study design, it asks about, evidence in terms of the Atkinson-Schiffer and multi-store model of memory, which I've interpreted as being about the serial position effect. So with this, we have the primacy effect, which describes a superior recall at the beginning of a list. And then the idea behind this is that this is showing that we have a distinction with our different stores of memory, because our information that we have at the start is more likely to get into long-term memory. That's then suggesting, okay, we do have these different stores. The recency effect describes serial recall at the end of a list. So we're going to have a stronger ability to remember what was at the end or at the start compared to in the middle. The reason we can remember things more strongly at the end is because it's more likely to still be in our short-term memory. And we can demonstrate this by giving someone the task where they have to remember a list of things. And then if you give them a distractor task so that it goes out of their short-term memory, because it's been more than 30 seconds of them focusing on something else, then you don't see the recency effect anymore. So this provides evidence for our multi-store model of memory. Right, we have a VCAR question here from the 2017 sample exam, and we're asked which of the following statements about short-term memory is the most accurate. Short-term memory holds only information transferred from sensory memory. All incoming information is held in short-term memory for approximately 30 minutes. Short-term memory holds all sensory information until it's encoded into long-term memory. Or short-term memory holds a limited amount of encoded information while it is being processed. Our correct answer here is not that it's A, because when we retrieve things from our long-term memory, we're going to hold it in our short-term memory. It's not B, because it doesn't hold all of the information, and it's not for approximately 30 minutes. It's, up to 30 seconds. And then it's not C, because not all of our sensory information is going to get in there. Our short-term memory is limited in duration and capacity. But it is D. Short-term memory holds a limited amount of encoded information while it is being processed. So we'll now go on to our different types of long-term memory that we have. Our long-term memory we can separate into explicit and implicit. So we'll look at explicit first. This is also sometimes called declarative memory. You can kind of declare that it exists. You're very consciously aware of it, explicitly aware. And that's broken into our episodic and our semantic memory. So your semantic memory is more your memory of kind of detached facts and things that you've learned. For example, my knowledge of the VCE Psychology curriculum, right? That's in semantic memory. Episodic memory, often we think of as being like the episodes of your life, the different things that you've actually experienced. So for example, if I'm remembering, giving a lecture on VCE Psychology, then that would become more about my episodic memory. With our implicit memory, this can be a bit harder to consciously identify. So this might be things like procedural memory. I can ride a bike and I can go on a bike and then pedal it, but I couldn't really articulate to you all of the reasons that I can do that and what changed from when I couldn't to when I can, or being able to touch type, or, having that knowledge of when you're playing an instrument. That's all in your procedural memory. So often questions on this, you might be thinking about sports skills, for example. We also have classically conditioned reflexes as another type of implicit memory. So for example, Albert's classically conditioned fear response that he obtained. So this is an overview of different things that you need to know back on that previous diagram. So your sensory memory, knowing capacity, duration. If we pay attention to it, it can go into our short-term memory, capacity, duration. Then it can be consolidated into our long-term memory. Again, you need to know the capacity, the duration, and then you want to know the different types of long-term memory. So all of this is accessible content that has been in the study design for a while. Now we want to look at our different brain areas involved in memory. So we have a few changes here from the previous study design. We're now going to refer more specifically to the neocortex instead of just the cerebral cortex in general as the site of our long-term explicit and declarative memory storage. Different parts of the memory stored in different places, more related to where they're processed. So something with a very strong visual element, I'd expect to see more activity in the occipital lobe, for example. With the amygdala and the hippocampus, we know that the hippocampus is involved in consolidation of explicit and declarative memories, as I mentioned before. It's also involved in our storage of emotionally charged memories, but not implicit memories. So if someone has damage to the hippocampus, then you might, find it more difficult to teach them that, this is my name or something like that, but they might still be able to learn how to knit, or how to, shoot a hoop or whatever it might be. The hippocampus also contains place cells, which create a mental map, thought to have a role in spatial memory retrieval. When it comes to the amygdala, this is involved in the formation of emotional memories. For example, your classically conditioned fear response. So you can have adrenaline stimulate the release of noradrenaline, which is then going to interact with the amygdala. The amygdala will then know, okay, well, because there was all that adrenaline around, this must be something important. So I'm going to attach emotional significance to the memory and signal the hippocampus to be like, hey, make sure that make sure that this gets stored really well. This might be important for our survival. New to the study design, we look at the role of the basal ganglia in memory. So we previously had in the previous study design that we knew an area of this is damaged in Parkinson's disease, which is responsible for the production of dopamine. But by investigating memory in people with Parkinson's disease, we can learn about the role of the basal ganglia in memory. So this has revealed impairment in incremental learning. So people with Parkinson's disease had more difficulty forming stimulus-response associations. This was further validated using experiments on animals, but it was specifically for trial-by-trial feedback. It's not that people were less intelligent when they had this impairment. It was specifically if it was doing something, seeing the response, then you had people who had damage to the basal ganglia show lower performance. But if they were just given all of the information about the trials and the outcomes, you had equal performance. So what I would do here is make sure connect this to the role of dopamine that you've learned about as a neuromodulator. Dopamine is important in the reward circuit, and we know that rewards, and we're thinking about trial by trial feedback. It makes sense that we could see a weaker response to that. We also look at the role of the cerebellum, which is located at the base. So this is important for our procedural memories. So this might be our particularly skilled, precise movements like touch typing, a knowledge of where we should put our fingers in terms of playing an instrument. It's involved in the encoding and storage of our implicit memories. So again, procedural memories being a type of these. So you notice here of X through the cerebral cortex, that was a previous study design terminology, and put in a summary of our different roles that we have in here. Most of these you can get from previous study design questions. Again, I highly recommend doing the previous study design exams and make sure you get all of those done, because there are still large areas of overlap where you do have a lot of that content in there and you can really benefit from that learning. When you're looking at the effects of brain damage, you go, okay, well, I know what this area is responsible for, so if that gets damaged, we're probably going to have an impairment in that area. As we talked about, for example, with the basal ganglia being damaged in people with Parkinson's disease and how that impacted their memory. So we have a summary of that here for your reference. The hippocampus, we're going to have difficulties consolidating our explicit memories in particular. Amygdala, we're going to see less significance attached to emotional memories. So this doesn't mean that people can't learn, but if something's particularly emotional, we might normally expect that to be stronger. We're not going to have that so much. You're not going to have the same fear response. You're going to have a reduced ability to acquire a classically conditioned fear response. With the cerebral cortex or neocortex, it's going to depend on where it's damaged in terms of what particular effect we have, but we know that that's used as the storage for memory, so we can see impacts there, and our cerebellum issues with implicit memory. One thing we also look at with memory is this idea of reconstruction and how we can reconstruct memories. In the previous study design, we focused more on this through the lens of like Loftus eyewitness testimony, in terms of how we have the fallibility of eyewitness testimony, because we can easily suggest someone to have a false memory. When we have memory reconstruction, we're going to combine actually remembered information with other available information to make a more complete memory. So this can be a liability, like we look at in Loftus eyewitness testimony in the previous study design, but it can also be a strength and make it easier to use your connections to draw out more memories and bring that knowledge in. So we're filling in the gaps of a memory. When we form a long-term memory, we're going to be encoding and organizing the details of the memory using different areas of the brain, linking together these neural networks. When the memory is later retrieved, we retrieve the encoded elements and we're going to reconstruct the memory. So in doing so, and we're filling in the gaps, we're like using links, but we can also have errors from this. In this study design, I would focus on integrating reconstruction with our other topics in learning and memory. For example, when we're looking at approaches to learning that situate the learner within a system, which we talked about a little bit before, and in how information from different areas of the brain can be combined. You'd also want to consider how this varies in individuals with Alzheimer's and/or aphantasia, who may have less information to lean on when it comes to doing this process. So when we're talking about aphantasia, this is the inability to voluntarily form mental images, real or imagined. So like I have aphantasia, me personally, I cannot picture anything. When I dream, I do not see anything. We went to like some kind of excursion and we're meant to be seeing what like it's like dreaming, and I was being to my classmate like, why are they playing a video? You can't see anything when you're dreaming, your eyes are shut. So not everyone with aphantasia doesn't actually see things in their dreams. There are some people with aphantasia who do. In my case, I also don't have any visual imagery there, or anywhere else. So aphantasia is thought to affect about 2% of people. And generally, because you're unable to use these like visualization strategies, you tend to use other techniques, for example, more focusing on words. And in recent years, there's been a kind of surge of research interest in aphantasia. A lot of people actually don't know I have it, don't know they have it. I know I used to initially think that when people were talking about visualizing stuff, they were just speaking metaphorically. And so I was a bit confused. So this isn't a diagnostic test, but just to give you an idea, imagine that you have a bowl sitting on your like desk or table, someone comes along and pushes it off. And then consider these questions. What color is the bowl? What texture does it have? What does the person who pushed the bowl look like? So I asked this of someone who doesn't have aphantasia, and they like had answers to these different things, because in the process of imagining, they're kind of constructing a visual scene. But when I answer these questions, I didn't really consider that kind of information because I didn't need to, because I wasn't creating a visual scene. So it didn't occur to me to include that in imagining this scenario. So this can have an impact on autobiographical memory. So my inability to visualize extends to reconstructing the past and constructing the future, as the study design phrases it. So when we're talking about this, if you want to look it up online, sometimes people refer to it as like severely deficient autobiographical memory, or SDAM, but that term's not in the study design, so I wouldn't worry about it unless you want to use it to look up more info. When we talk about autobiographical memory, it's like referring to itself, biographical. So you're thinking about your knowledge of your own experiences. And so in general, people with aphantasia have impaired memory, and there's some research that's come out of New South Wales that's really suggesting that even though, yes, we knew that this is connected to deficiencies or impairments in like your autobiographical memory, that it also extends to other areas as well. For example, in a short-term memory, that you can have issues with that. That being said, I memorized like hardly anything for VCE Psychology, at least intentionally, and certainly got A+ on the exam and all of that. So the effects can look different. When we're thinking about this and like why it might happen, which is a question a lot of people are interested in, it's thought that visualization requires reactivating the neural pathways that you used when seeing an object, and that maybe people with aphantasia aren't able to do this very strongly. So they did a study where they compared people with aphantasia who have no ability to visualize to people who have hyperphantasia. So they have a really strong, like vivid ability to create these like lifelike visualizations. And they found that for the people with aphantasia compared to those with hyperphantasia, people with aphantasia had weaker connections between their visual occipital network and the prefrontal regions, and weaker connections across from the left hippocampus and other areas of the brain. So it might be that there's a neurological basis behind this. Of course, this is correlational, right? So we don't know if it's maybe people with aphantasia, because they have it, are using them less, or they have these weaker connections and therefore they have aphantasia. So we don't really know the direction there. Sometimes the question has come up like, how do we know that people with aphantasia are actually kind of being legit? Or maybe they like experience the same things as people without aphantasia, but they're describing it in a bit of a different way. And so, that's why we're getting these different reports. So one of the things that they've done is researchers looked at a study where they had people without aphantasia asked to imagine light and dark objects, and it changed the amount of light that they had entering their pupil, and when they did that visualization. And people with aphantasia were also asked to do the same thing, and they got different results, because the people with aphantasia, when they were asked to visualize something light or dark, they didn't change how much light was entering their pupils. They did also do a kind of check to see if people were really trying in there. You can also look at things like binocular rivalry experiments. So, for example, where they would show different images to each eye. If asked to visualize something in advance, then that can bias what competing image is seen. You don't see that effect in people with aphantasia. When we're looking at memories, one of the things that often people might be interested in are in terms of our failure to retrieve memories. So you have brain trauma as a general term referring to any brain injury that's going to impair the functioning of the brain. You can have amnesia. We have a loss of memory more substantial and not consistent with normal forgetting. And specifically anterograde amnesia, where you're unable to form memories after the trauma occurs. So you're not going to be able to store new memories, but you can access your pre-existing ones. However, this is generally restricted to declarative memories, so they can still form new implicit memories. This is found to be associated with damage to the medial temporal lobe area, particularly the hippocampus, which makes sense because we know that the hippocampus is responsible for consolidation of our declarative memories. So if we damage it and we reduce the ability of it to do its job, it makes sense that we are going to struggle to form and consolidate any new declarative memories. In terms of memory, in the past this has been pretty heavily examined, needing to know your different things, know things like duration and capacity of different parts of the memory. Very easy to be asked that. Know your different areas of the brain. Often people get confused on those things. Now we're going to go on more onto some strategies that can be used to assist with memory. So a mnemonic refers to any kind of memory device or aid that you might use. And when we're looking at the study design dot point on this, VCAR makes a point of saying that they help with encoding, storage, and retrieval. So we want to make sure that we think about all three of those parts. Encoding, where we successfully form the long-term memory. Storage, where we are able to maintain that memory in storage. Or retrieval, where we can access that memory, bring it from our long-term memory into our short-term memory. Remember, don't just focus on retrieval. VCAR will have specifically mentioned all three components for a reason. So if asked to describe mnemonics, make sure that you think about all three. This is something that's new to this study design. You do have some references to mnemonics from past study designs, not the one just before, but earlier than that. But they are, it's not a very good hunting ground for past exam questions on this. So you will need to make sure that you use some more of your own resources and techniques to make sure you've got this information down and not rely on the past exam questions. We have a dot point here where it talks about the use of mnemonics, acronyms, acrostics, and the method of loci by written cultures to increase the encoding, storage, and retrieval of information, as compared with the use of mnemonics such as sung narrative used by oral cultures, including Aboriginal people's use of songlines. So in relation to this, I found this study, which I thought is great because it's very approachable and succinct. It won't take you much time to go through it all, but it is very, very related to this dot point. So I'm going to go through some of the findings that we had in regards to this and explain some of the context here. So songlines are an example of a mnemonic or memory device used in oral cultures, and they use the power of autobiographical memory to aid in memory retrieval. So in the Monash study linked on the previous slide, an elder guided students through a rock garden located on campus, Monash University, and the names of butterflies were tied to particular locations and features in the landscape through place-based narrative. So remember again about how we had in learning that previous dot point about how knowledge was patterned on country. Connect that through in this as well. This was contrasted with the memory palace technique, which is a mnemonic used in written cultures. Again, this is focused on locations. We're looking at the method of loci here, where we're tying things into particular places. So the students visualize a place they know well, and then they kind of place objects symbolizing what they want to remember along a route going through that place. So in this case, it was knowledge tied into the butterfly names that they would store and then kind of mentally place within a location they're familiar with, for example, their home. Then when they're trying to recall the knowledge, they visualize that home environment and then kind of walk on that path where they've placed the objects on there, with the objects acting as cues for the information that they want to remember. This is a technique that I can't use because I can't visualize things, but this is often thought to be one of the most successful techniques used if you're competing in memory championships, for example, and you're really trying to remember a lot of knowledge. So there's heaps of information about it online and how to learn it and use it, and it's thought to often be very highly effective. In terms of the results that they found from their study, students who used either the memory palace or the songline techniques had superior recall compared to students who were just given a list of the butterflies to memorize and not taught specifically any technique. Students were most likely to go from low recall to remembering the whole list of butterflies if they used the songline technique, and there was some advantage there in terms of making less sequence errors. You can, look at the exact data in there. They did try and do some follow-up studies where they looked at it after a longer time period and some differences there. And they did have some results from that, but it was a very small sample size when they looked at the later week ones. So I would be a bit cautious about the validity there. But before we go on from memory, final thing I want to say in terms of your written methods that you need to know, be careful with the difference between acronyms and acrostics. So with the acronym, you're just going to take the first letter from each one, and with the acrostics, you're going to then use the first letter to make a new word. And so make sure you have the difference between those two down and use a lot examples of those. Practice trying to use them to remember psych knowledge and using your mnemonics in that way, so that you can make sure that you're very familiar with the techniques and hopefully gain some benefit to your study as well. In general, some of the other guidance that's been given for memory in regards to using that sung narrative and songline technique is to consider that we know that this can have a lot of efficacy because we can look, and there were some examples I had earlier, from various different locations where memory has been retained and passed down for over thousands of years. So if you're interested in that, try to look up examples, again, specific to your area, or there are some examples that I think are relatively more well known, such as the Gunditj Mara, people's knowledge in terms of Buj Bim, and the Bushfield Axe, and with the information around that you can look at. Alright, so let's go on to our scientific skills, which are something that's a consistent source of struggle for students across the years. You can be assessed on this at any point in time. It's often integrated in, so do not think that this is just going to come up for the scientific poster. And remember as well that the scientific poster does not have to be done at the end of the year. Many schools bring that forwards earlier, and don't just focus on Unit 4 area of study 3, that maybe it's place in the study design, but it can be much earlier. So let's look at some of these components. A hypothesis is a testable statement that predicts the relationship that you expect to see between your variables. For the components of your hypothesis, you can use iPod to remember that. So when we're using iPod here, we are using it as an acronym to remember independent variable, population, operationalize, dependent variable. For example, Australian adults who read at least one book per week will score higher on a standard IQ test than Australian adults who don't read books at all. So we've clearly got our population in there of Australian adults. We've then operationalized our independent variable who read at least one book per week. So we're not just saying who frequently read or who like reading. We're making sure we have something very specific to go after. And then we have will score higher on a standard IQ test. So we're not saying is smarter. We're doing something that we can very easily measure and test, which is the IQ test score. And then we've got the comparison back to our control group. In terms of these conventions, depending on your teacher's preferences, you might actually be able to use language like I and we in your scientific report. And the reasoning for this is that it's more traditional to stick with agentless passive. However, there have been arguments made in more recent years really focusing on the fact that it can be more difficult to understand agentless passive and that you can still have subjectivity in it anyway. So you may actually be able to use I and we. I would just make sure that you check with your teacher first before you do that in case they have a preference against it. But do stick to using unemotive and objective language. So the result was significant. That's something that has a measurable threshold, or we can talk about it being substantial. You don't want to put really emotionally charged language in there like amazing for who? What's the standard for amazingness here? Right? So trying to stick away from that more emotional side of things. And use specific jargon to really show off your understanding of the content of VCE Psychology. For example, the memory was retrieved, recall was tested, not focusing on, just generic they remembered. Try and make sure you show your understanding of that psych terminology. Another one that's going to be really important for you is to be succinct. This has always been important to an extent, but now that the scientific poster has gone down to having that smaller word count, a lot of your space on the poster is going to be taken up by that statement that you need to make. If you're unsure what I'm talking about, Vika has specified the format of your poster and that 600 word limit in the study design. So make sure you read that and you know the different sections that you have. As always, the discussion is worth a lot of marks, so you're going to want to use a fair bit of your word count in there, but make sure that you absolutely stay succinct because you do not have the words to spare. I find that students often overwrite their methods and sometimes their introduction. There can be a tendency to just spend a lot of time on that and then go, oh no, I've got half an hour left and I haven't done the rest of it. So be careful of that. In terms of our experimental designs, we have independent groups, which is the kind of classic. We have a control group, an experimental group. We want to have random allocation so that biased allocation isn't responsible for our results and isn't acting as a confounding variable in there. This is going to be relatively cheap, low time, and we can have generally a large impact from individual participant differences here. So for example, if you're doing a test and you want to see does chewing gum make a difference in the exam score? And then you go, okay, well, I've got two different classes. We're going to test them both on their knowledge of maths. This is the English class and this is the specialist maths class. Your results might not be due to the chewing gum, right? So you want to make sure that you have random allocation, and that you also try and have a large enough sample size in there that you're hoping these individual participant differences might balance out a bit. But we might go, you know what, I'm a bit too concerned about these individual participant differences, so what I'm going to do is I'm going to pick a characteristic that I think is important, for example, previous exposure to maths or math scores before I give them a math test, and I'm going to match the participants on that. So, okay, these are the two that got the high scores. All right, one goes in this group, one goes in the other group. So your really ideal case study that you'd get for this is if you had identical twins, so you knew that they were really similar in terms of if they were raised in the same household and they had the same genetics. Generally, you're not going to get them that similar. You're going to have to pick some characteristics that you think are important. So you've got generally a lower impact from individual participant differences here, but you're going to have to spend more time on trying to go, okay, what do I match them on? How do I match them? Okay, so I've got to get the information about, how they are on this metric so I can match them up and do that. So it can be a bit more intensive in that way. We've got repeated measures, where you, rather than being like, okay, let's see how people exposed to this go compared to people exposed to that, we'll have the same person, who does the control and the experimental conditions so that we're not seeing any individual participant differences. However, you could get order effects. If you're like, okay, do this math test, now do the math test with chewing gum, you might, see an impact from there. So generally what you want to do if you're having a repeated measure study design is that you'll use counterbalancing. So you're going to randomize the order that they do it in such that an equal amount do it in each order. So some will do chewing gum first, some will do no chewing gum first. And then you're hoping that any order effects are going to balance out, and you've addressed that by counterbalancing. So you haven't gotten rid of it by counterbalancing, but you're hoping it's not going to impact your results because they're balancing out against each other. One issue with this is if you're making the same person do your different conditions, they're going to have to spend longer in the experiment. And if you're trying to get people to sign up to your experiment and then you tell them they've got to spend longer in it, they might be more likely to quit partway through or decide that they don't want to do it. So that can be a bit of an issue, as well as it taking you, the researcher, more time as well. So we have some kind of population that we're interested in. We're going to sample from that population for our experiment, and then we're going to allocate them into, for example, our experimental group, our control group. if you're doing a study at school and you're thinking about what population you want to investigate, I would suggest that you choose a population that you have more easy access to. For example, you're unlikely to be able to really draw conclusions about all Australians based on a study that you're doing, because your sample size compared to the population of all Australians is very unlikely to be representative, right? So you might want to pick something where your sample is going to be able to be more representative of your population. We also want to try and make sure we can, reduce all different sorts of extraneous variables, potentially confounding variables. One of the things we can do is run a single blind procedure where the participants are unaware of whether they're in the experimental or the control group, and therefore they don't know if they've been exposed to the independent variable you're interested in. So this avoids issues with participant expectations, as all participants equally feel like they're receiving a treatment. Commonly, this isn't really fully understood by students. So if you put someone in an experiment and you're like, hey, we want to see if this improves memory, they might be thinking, hey, I'm going to get something that improves memory, and they're going to rate their memory higher, right? Or they might feel like, oh, that's the result you're looking for. I don't want to disappoint the experimenter and, put it there. It's not necessarily a conscious thing, but it can happen. And so you're not going to be able to get rid of that. And instead of trying to get rid of that and trying to remove the placebo effect, what you do is you make it so that everyone gets the placebo effect, including the control group. That way, when you compare the results, you go, well, they both had the placebo effect acting on them. Therefore, I expect that the differences aren't due to the placebo effect since they both had it. They might be due to our actual variable that we're investigating. With a double-blind procedure, you take it a step further than the single-blind, where it's not only that the participants don't know who's in what group, the experimenter also doesn't know who's in what group. So they're not going to, again, potentially accidentally, treat the participants differently because, oh, hey, I expect that you're going to have a better score, so I'm just, going to give you a higher rating or whatever that might be. And it's not necessarily someone being nefarious and deciding that they're going to mess with their experiments, but we have all sorts of biases that can affect how we see things. What you really want to make sure of is that anyone who's interacting with the participants or who is responsible for judging them, particularly when you have something quite subjective going on with interpreting behavior, for example, that they don't know who is in what group, so that they're not being biased. We also want to be able to describe our results. And so we have our measures of central tendency, like mean, median, mode, but we also have our standard deviation, which describes the spread of data. If you've ever found the interquartile range, it's a kind of similar concept. You calculate it differently, but it's about going, how spread out is your data? So a high standard deviation on a bell curve looks something like this, where it's more spread out, whereas a low standard deviation, they're more clustered together around the central value. So for our large standard deviation, a box plot on this would likely be a bit more, let's draw this properly, we'll have our middle line in here, it's going to be a bit more spread out. Whereas for the low standard deviation, where it's quite clustered together in the center, we would see it take on a narrower range of values. You don't need to know how to calculate. I wouldn't be worried about that. If you need to calculate it for your experiment, you're just going to go into something like Excel or Google Sheets and do equals standard deviation and find it that way, right? You're not interested in the nitty-gritty mathematics behind it. What you're interested in is that it tells you about how much variability there is within your data. Okay, so you've got your data, you think you know what your results mean, and then you want to go, does this just tell me about the sample I investigated? Or can I take the results from this sample and say that they apply to my population that I was interested in? So in order to make a generalization, if you haven't breached any ethical guidelines, you haven't had any major extraneous variables that could be reducing your validity because they're providing an alternative explanation instead of it being your independent variable that's responsible for the changes, and you think you've got a representative sample, then you might be good to go. So in order to get a representative sample where, yep, this represents the population, you can't have used convenience sampling. It has to have been random or stratified sampling. And the sample size also needs to be large enough. If you randomly pick one person, no matter how randomly you pick like one or two people, they're not going to represent a whole population, unless they're the only members of it. So you need to make sure that you have a large enough sample size too. Then when you can generalize something, we can talk about the external validity of it, that we can apply this out as a general concept and how this is actually useful. But if your study didn't have internal validity, that is that your results weren't actually due to what you think they were. You thought you were measuring the impact of the independent variable and the dependent variable, but actually some confounding variable snuck in and was making those changes, then you can't do it. In order to generalize, you need to have your internal validity. Without internal validity, you're not going to have any external validity. Often you might have some kind of scenario where you need to consider the various different limitations that an experiment has and suggest a solution. Some of them are pretty straightforward. So for example, if you have a small sample size, then you want a larger sample size, right? So get more participants in. If you had individual participant differences having an impact, a few different things you can do. If you had an independent groups study design, you could try matching your participants. You could also try increasing your sample size and making sure that you're using random allocation. You could also use a repeated measures design, which is going to count those individual participant differences even more. If you use the repeated measures design, however, then you introduce the potential problem of order effects, which you address via counterbalancing. If you have the placebo effect, that's, it's normal that you have it. So what you do is you make sure that the control group has the placebo effect too. And then that way you can effectively use your control group as a baseline against which you can compare the results for your experimental group. That phrasing is important. Again, a lot of people make mistakes in terms of not really understanding why we use placebos. So make sure that you understand that if you use a placebo for the control group, both groups have the placebo effect, but now your control group is going to provide a more comparable baseline against which you can explain your experimental results as being due to your independent variable instead of being from the placebo effect, because that was already accounted for. Note I'm saying accounted for and not that it was removed, because you're not getting rid of it. If you have non-standardized instructions, you'll want to standardize these. So if, for example, you're presenting on a poster, you might have your standardized instructions being an appendix that's attached to it. If the experimenter effects could be introducing bias, use a double-blind procedure to make sure that you're not going to have the placebo effect or the experimenter effect being an issue here. For the placebo effect, we now want to use a placebo, which we can also talk about with single blinding, and a double-blind procedure encompasses the same thing here, in addition to countering the experimenter effect. If you use convenience sampling, try using a more representative method in order to address that in future, like random or stratified sampling. One thing I would say here is that it's not, the end of the world if your experiment that you do has some of these problems. There's a reason why people use convenience sampling, because it's convenient and you have access to those participants, and it can be hard to recruit people. The important thing is to make sure that you demonstrate your awareness of it, how you would try and address that, and go through. If you can design an experiment that doesn't have these issues in the first place, even better. But sometimes you are going to have these things and you can't necessarily fix them because of your limited resourcing or your limited time. So make sure that you show awareness of how it would have an impact and how it could be addressed in future research. In terms of ethics, I want to highlight here that for the new study design, you need to make sure that you know not just your normal ethics that you would look at in previous study designs, but we have additional ethics as well. So make sure that you are on top of that and that you Remember all of your different terms that you need to know and the difference in terminology for when they're asking for different ethical things. So here we've got some basic concepts that you can look at in terms of important principles behind ethics. With confidentiality, I am going to quickly note here that confidentiality doesn't just mean that you're not like putting their full name in there. It means that you don't have them able to be identified. So if you didn't put their name in, but you had enough other stuff that like someone who knew them could figure out who it was, you wouldn't want to do that. You'd want to make sure that you took out that information so that no one could be identified. Often if you're doing research, there'll be rules around how the information needs to be handled to make sure this is upheld. With withdrawal rights, make sure you're aware of the fact that it's not just that participants can withdraw, but also their data. So they can decide, you know what, I don't want my data to be used for this that you've already collected. Take that out now. In terms of informed consent, remember that this encompasses a range of different information. So nature and purpose of the study, potential risks, and information about their rights as well. All of those things are important. And if you're dealing with children, then we need to have parental or legal guardian consent in there. With deception, we know that sometimes that's allowed, requiring permission from the ethics committee. But you have to make sure that participants are informed of the deception after the study has been completed. So for example, I did one of those like survey-based studies. At one point, it had deception in there. So they had a question near the end asking about what did you think the aim of this study was, to kind of see if anyone had figured it out, because that could influence the results. And then they afterwards debriefed you and informed about, the deception that had been used. When that's the case, there'll be a reason why they've put it in there, because otherwise they won't be able to collect those results. So it has to be, weighed against any potential harms. If the deception was likely to cause significant harm or trauma, then that should not be allowed by the ethics committee. With debriefing, this is also a chance to address any harm and provide participants with information about the results and any conclusions that have been obtained from the research. Here we have a practice exam. This one I took from the Western Australia 2019 exam, just so I could be fairly confident you wouldn't have been exposed to that previously. I don't actually recommend going and looking at other states in terms of getting these unless you're running like really out of the VCE ones, because the VCE ones you can look more specifically at what VCAR tends to ask. So I would go there. If you look at the exams before 2017, instead of having the 10 marker at the end, like what we're going to have in this exam this year as well, that we've got from 2017 onwards, in the previous study designs, they had a section C, which was focused on research methods. So if you specifically want to get research methods practice, you can, go into the old exams and look at the section C questions to try and specifically target that knowledge. Okay, so our question here is that we have, at a university, 40 first-year psychology students participated in a study examining the effects of loud music on typing accuracy. Students were given a typing test to complete, with 20 students listening to loud music through headphones and 20 students without music. At the end of the test, the total number of mistakes was calculated for each condition. We need to identify the independent variable, the dependent variable, and then two uncontrolled variables in relation to the participants in this study. Let's go through the answers for this. Independent variable in the study, listening to loud music versus no music. So we could tell that pretty clearly because that's the thing where we're trying to say, okay, IV, impact on DV, effect of loud music, IV on typing accuracy, DV. So the dependent variable in the study, number of mistakes made / level of typing accuracy. And then two uncontrolled variables in relation to the participants in this study. So answers could include things like what the students ate or drank prior to participating, how much sleep they got the night before. We'll go through this a lot more in Unit 4, where sleep can have a whole range of impacts. So sleep deprivation, you would expect to see differences. If students had prior typing experience, hearing impairment or ability, or other relevant responses. So only accept responses that could affect that variable. So you'll see here, none of these were explicitly listed in there. If you were told something like students were matched based on criteria, then you wouldn't identify that as an uncontrolled variable. Right, so here we have some tips in terms of psychology. Psychology does have a lot of content, so you want to find a way that you can try to trim it down. And particularly because it's a new study design, think about creating some of your own resources. I always recommend you have the study design as like your best friend throughout the year, but with this being a new study design, that is especially the case. You may find that there are some differences between how teachers at different schools have interpreted the study design. So try not to rely too much on necessarily, what your friends are saying, they got on the test or that kind of thing in terms of their questions. It can vary a bit in terms of interpretation, particularly with these new study designs. So try and make sure that you're really comprehensive with what you have. A lot of the information that you get in a range of resources isn't actually examinable, so use the study design and guidance from other figures such as teachers and tutors to focus your energy on the things that are most important. Really do make sure you don't neglect those practice questions. Yes, it's a new study design. Yes, there's new content that isn't in the previous ones, but there's so much content in the previous study design exams that is examinable. Make sure you still really nail those practice questions and that you put a lot of effort into it. It's a subject that often people can do really well at. Another thing I would say here is that as you go later throughout the year, we learn more about, the negative impacts of sleep deprivation. Really try to make sure that you're getting enough sleep. I know it can be hard, particularly in year 12 when you've got so much going on and so many different pressures. If you already largely have learnt the content, it is often not going to be worth it for you to stay up late the night before an exam or the night before a SAC studying. Try to make sure that you do get sleep so that you're not having those negative consequences in terms of impaired learning and memory and focus, attention, all of these issues. You really want to make sure that, to the extent that you can, try to take care of your health and not put it completely on the back burner. I would also say for the new study design, there are going to be things that I find, if anything, often there's kind of over teaching of new study design content, because when I did psychology, it was in 2017. So it was a new study design for my year, even though it's a different one to this one. And I found that there were times where something would be explicitly listed as this is not examinable in the study design, and it would still sometimes be taught to people. So really do make sure that you pay a lot of attention to what's in there when it comes to the exam. Obviously your teachers are the ones marking your SAC, so pay a lot of attention to what they emphasize. And again, particularly when it comes to that new content in terms of that guidance for what might be assessed. You have the study design there as a resource for you. There are also extra materials that you can look at in terms of, for example, the advice for teachers in terms of planning and implementation that you can look at. In terms of some of the suggested activities, for example, have articles that VCA have recommended in terms of this new study design. So I've tried to simplify some of those down and, things like the gut brain axis flowchart. But you might find that some of those, not all of them, but some of them are pretty approachable and you'll be able to learn well. And try to pay attention to the way that VCA has phrased things in the study design. For example, one of the concepts that I came across when I was looking at knowledge for the study design is the idea of the 8 ways of knowing. And there were specific list of things that you needed to know in relation to that. But I suspect that if VCA wanted us to really know and memorize those 8 things, they would have phrased it in terms of the 8 ways of knowing, for instance. So while it can be useful for you to look at those themes in terms of learning from the community, for example, I wouldn't approach that as a list of 8 things to learn, and I would instead focus on your understanding and how you can tie this into other areas of the study design too. All right, I want to say thank you very much for your engagement and participation in this lecture. I highly encourage, asking any questions that you may have. And before I go, I am going to say, again, as someone who did a new study design, I know that this can be quite overwhelming. I know it can be very stressful, but the study design will help you a lot if you pay a lot of attention to it and you have those resources there. There are other resources available in order to help you. You can look at some of that extra guidance if you get really lost. Some of these things I've gone through in less detail than what you have written on the slide. So make sure that you go back through and that you actually read those dot points. There is still a lot of guidance that you can get from those past exam questions in terms of what points you need to know. You also have the lists of different cognitive verbs to know. And a lot of people who take Psych Units 3 and 4, it's their first Unit 3 and 4 level subject. So make sure that you really get used to that phrasing of, okay, if this is a justify question, I need to make sure I talk about these things. If this is an explain question, I need to talk about these things. I commonly get asked about strategies in terms of the 10 marker, particularly as we get more towards the end of the year. For those really high mark questions like that, make sure you're doing things like highlighting and annotating and then creating a rough kind of plan to help you make sure that you cover everything off that you need to be discussing. I often find that people will make more silly errors, things like misreading the questions if they're going through the questions more quickly. So if you have an hour spare at the end of an assessment, maybe consider slowing down next time so that you have more time to read through the questions more thoroughly. If you struggle with missing those key words, making a mistake on that front, again, go back, underline. After you do an assessment, take note of the mistakes that you made and put that into your log of mistakes, which is also where you should be reporting in exam questions that you've gotten wrong. So then you can identify trends in the kinds of mistakes that you're making and target those more effectively. So in an effective log of mistakes, I would include things like the topic of the question that I was looking at, what the specific question was, the exam year, that kind of thing. And then about, okay, this is what the question was. This is what I answered. This is what I was meant to answer. And so what I need to change. And then I'll try and categorize it. It is so much easier to improve if rather than knowing that okay, I'm getting X percentage and I want to go to Y percentage, if you can go, well, I tend to be making this kind of mistake. And so I can specifically focus on that. The more specific you can get about what you need to work on in terms of your learning, the easier it's going to be for you to tackle those things. So that is something that I very highly recommend. Another thing with psychology that people often can lose marks on is not being quite specific enough to the scenario and applied enough to the scenario. A lot of the time, and you see this in a range of subjects, what VCAR doesn't really want is just the generic copy-paste answer. They want something that shows that you actually read the scenario and thought about that and integrated that in. If you see a question that's really challenging and it's throwing you around a lot and you're like, oh, I have no idea what I'm meant to respond for this, chances are that there are other people thinking that thing too. And so one of the advantages of VCE being very competitive and ranked in its nature is it's okay, well, if other people are, struggling with this too, then, in the end, it may not matter so much that I struggled on this, but make sure you get in the habit of writing something down anyway. I know that, when you're doing your practice at home particularly, you may go, look, I don't know this, so I'm just not going to write something down and I'll skip it. Try and get in the habit of putting something on paper, because when you start to allow yourself to, write even the foolish response, you're like, this isn't going to get me the marks. Just, if you get in the habit of getting something down, you might find that you're more, kind of open to those different ideas, and it makes it easier to actually think of what the correct answer is. And you want to make sure that for your assessments, you can't get marks if you have nothing there. If you put down something there that you think is maybe a bit rubbish, or, maybe this is completely off the wall or off base, at least you've got the chance to get marks. With nothing there, you have zero chance. You're not going to get, negative marks for a question that you were otherwise going to leave blank. So make sure you get in the habit of getting something down. I have seen past VCE Psychology papers where, because of how the question was phrased, it ended up that all of the answers for multi-choice were marked as correct. So you just had to put something in and you would have gotten the mark. That doesn't happen very often, but you don't want to be a student who, would have otherwise gotten the mark and you miss it because you just didn't shade a bubble or you didn't put something down. So make sure that you're really trying to give yourself your best chance by putting something in there. So there is something that they can try and award marks to. Try your best to go for something that's really accurate and specific if you can, but something is better than nothing. And that's also valuable advice when it comes to your study techniques. So when you're struggling with procrastination, something that a fair few of my students have found useful is the 5-minute rule, which is where you don't want to do anything, just do it for 5 minutes. And so, 5 minutes of work might seem like it's basically nothing, but it's building the habit in you of getting used to approaching your work. And the other thing that it's doing is that often the hardest part to overcome is actually that barrier of starting the task. You might find that when you're at the end of your 5 minutes, you're like, you know what, I just really do need this break. I don't want to do this. And you drop it and that's fine. But often what can happen is because starting was the hardest part, now that you've actually forced yourself to kind of sit at your desk and go through and do this 5 minutes of work, it's a lot easier to continue. So really it's a win-win because either you got, 5 minutes done that you weren't going to, or sometimes you'll get a whole lot more done than what you're actually going to if you just kind of gave into your procrastination. Sometimes you do genuinely need the rest, but another thing to think about as well is you might be happy to specifically forego like this bit of study, but are you also happy to train yourself in the habit of ignoring that study? I know that genuinely there are a lot of like pressures and time commitments that can come in and impact on that. But if you are struggling with motivation and just kind of phone scrolling instead, that's something to be aware of. Speaking of your phone usage, try to have your phone away and out of sight when you're studying, because even just seeing it, it can constantly drag your attention away, and you don't want to be doing that. Ideally, what you want to have is that when you're studying, you're just focused on your studying, and when you're relaxing, you're just focused on your relaxing, and you're not having that mingling between the two. The worst of both worlds is when you're sitting there feeling guilty about not studying, but you're not actually getting anything done. So try and make sure that you really plan in breaks, you segment that time across. Some people find things like the Pomodoro technique effective, can vary on that. With psychology, I sometimes get a lot of people who really like train definitions. Aside from observational learning and then near the start of Unit 4 where you're looking at like EEGs, EMGs, EOGs, I don't tend to recommend drilling definitions. I recommend having a good enough understanding of the content that you can describe in a really accurate and specific way the concept you're talking about. That being said, know your school. There are some teachers who really expect you to start off every answer with a definition, and if so, use that definition, use what they've taught you. They're the ones marking you, not me. All right, I wish you all the very best. Best of luck for your studies. And again, if you, on the live stream had any questions, thank you for engaging, and farewell.